Okay, I want you to imagine something. You're on a ship hundreds of years ago, and you are completely lost at sea. A huge storm has just rolled in, waves are crashing everywhere, and the sky, well, the sky is just this blanket of total blackness. You can't see the stars, you can't see the moon, nothing. How do you get home? This classic adventurer's nightmare is exactly where our story starts today. A story about an amazing, invisible force that literally changed how we see the world. This exact problem was on the mind of a young storyteller named Reshma. She was writing a story about ancient sailors on this epic voyage, but she ran into a huge wall. Her characters get caught in this awful storm and they can't see the sky at all. They're completely and utterly lost. I mean, that's a scary question, right? For Reshma's sailors, it was literally a life or death situation. But for Reshma, it was a major roadblock in her story. How on earth could her heroes possibly figure out which way to go? So what did she do? Well, she started digging. She searched online, she went to her school library, and she stumbled upon this piece of ancient technology that not only changed her story, but in the real world, it completely changed the course of human exploration. And that solution was the magnetic compass. It's such a simple device, but it didn't need the stars or the sun or even a clear sky to work. It relied on something totally different, an invisible force. But to really get how this little thing could save a giant ship, we need to understand what makes it tick. So let's pull back the curtain and deconstruct the magic behind the compass. And it all begins with the magnet itself. What even is a magnet? And where does it get this strange, invisible power? Okay, first things first. Not everything in the world cares about a magnet. The materials that are attracted to a magnet are called, you guessed it, magnetic materials. These are the kinds of things that seem to leap across a table to snap onto a magnet. So who are the main players in this magnetic club? Well, you've got metals like iron, nickel, and cobalt. But it's not just them. A lot of their combinations and alloys can be magnetic too, which means there are a lot of materials out there that can feel this invisible pull. And then, on the flip side, you have non-magnetic materials. Just think about the world around you for a second. Plastic, wood, glass, these things are completely indifferent to a magnet. It's like the force isn't even there for them. All right, so how does any of this help us find our way? Well, it turns out that every single magnet, no matter how big or small, has this sort of hidden directional code built right into it. And that code is all about its two poles. So imagine you take a bar magnet and hang it from a piece of string so it can just spin freely. One end of that magnet will always swing around to point towards the Earth's geographic north. We call this the north-seeking pole, or, just the north pole of the magnet. And as you've probably figured out, the other end does the exact opposite. It always points toward the Earth's geographic south. That's the south-seeking pole or the South Pole. And here's the really important part. You can never have one without the other. They always come in a pair. But why? Why does some tiny magnet in your hand care about which way is north or south? And this is the big secret. The reason is that our entire planet is basically one giant magnet. It has its own massive, invisible magnetic field with its very own north and south poles. And that is the whole trick behind the compass. That little needle inside, it's just a tiny magnet that's free to spin. And it's constantly trying to line itself up with the Earth's huge magnetic field. That's why it always points north-south, no matter how bad the storm gets. Okay, so we know a magnet can line up with the Earth. But what happens when magnets interact with each other? This brings us to the final piece of the puzzle, the really simple fundamental rules of magnetism. Just look at this. It's so perfect and simple. When you bring a North Pole close to a South Pole, they snap together, they attract. But if you try to force two North Poles or two South Poles together, you can feel them push each other away. They repel. It's this fundamental dance of push and pull. So it really all boils down to this. Opposites attract and likes repel. That's it. This one simple principle governs every single interaction between magnets, from the little ones on your fridge all the way up to the core of our planet. And with that, we're right back on that stormy ship. The sailors, now with their trusty compass, could find north. Because they understood that their tiny little magnetic needle was being pulled by the giant magnet right under their feet, they could find their direction, navigate through the storm, and finally find their way home. An invisible force made visible. It really gets you thinking, doesn't it? We just unpacked the power of magnetism, this invisible force that can literally guide us across oceans. So it makes you wonder, what other powerful, unseen forces are at play all around us, quietly shaping our world every single day?